All right, lesson 2 is on using the number line. Using the number line, oops, I'm going to get off to a good start here. Using the number line to model the addition of integers. So we're going to be focused on how do we represent adding integers. Okay, now remember integers are positive or negative whole numbers, including 0. Okay, so on a number line, if you look at this number line here, these are all integers. There's no decimals, there's no fractions. They're positive and negative whole numbers and include 0, which is neither positive or negative. All right, so let's jump right in. So suppose you received $10 from your grandmother for your birthday. Then you spent $4 on snacks. Using addition, you need to write an equation to represent the situation. So my rules for equations are they have to have some kind of operation, adding, subtracting, multiplying, or dividing. They have to have a variable. Now, it's probably not technically what an equation has to have, but for the rules, what we're doing in class, they need to have a variable, and they have to have an equal sign. Okay, if it doesn't have an equal sign, it's an expression. All right, so we received $10 from previous lessons and what we've learned in the past. That's a positive 10. Then we spent 4. Now I could say minus 4 here, except we need to use addition. So I'm not going to say minus 4. I'm going to say plus a negative 4. And that negative 4 represents spending money, getting rid of it basically. And that has to equal the total amount of money we have. So I'm going to say it's going to equal X, and I can use any variable. Again, this is not a letter being thrown into math class. This is a symbol representing something we don't know. So here's my equation. Now, how would we model that on the number line to show your answer? All right, so as of right now, we always start at 10. We start at 0, and our first number is 10. So I'm going to go from 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to add a negative 4 to that. So I'm right here at 10. I'm going to come above it. And the negative sign tells me go to the left 4. 1, 2, 3, 4. And where do we end up? Well, let's see. 10 plus a negative 4 equals 6. So our focus of today is using a number line to model this addition. And we're going to be introducing something called a vector, which instead of making like a bump method or whatever you want to call it. So let's jump into that as well. So complete the steps to find the sum of negative 2 plus 3. Negative 2 plus 3 is what we're focused on here. Yeah, that's a little better. We're going to model the equation using straight arrows called vectors. And that's what I was just saying. We've been kind of using like this bump method, counting method, and we need to use a straight line. And I'll show you that. So we start, remember, we're doing negative 2 plus 3 here. We start by placing the tail of the arrow on our first number. So in this case, on the negative 2. So if I come down here to the number line, this first one here, I am going to start at a negative 2. I'm going to write that here, negative 2 plus 3. So I'm not starting at, I'm sorry. Let me fix this. I'm jumping ahead. We start by putting the tail of the arrow on 0. Sorry about that. We're going to put it on 0. And then we're going to draw the arrow 2 units to the left. Oh, and I'm totally going to cheat at this, if I can. I'm going to go 2 units left. And stop at negative 2. So I'm sorry for the confusion right there. We're still starting at 0. Eventually we won't. The direction of the arrow is to the left because you are counting down from 0. And that's what we did in lesson 4.1. We're counting down. Start the next arrow at the end of the first arrow or at negative 2. Okay, so that's where we finished up. And we're going to draw the second arrow 3 units for this plus 3 here, for this plus 3 right here. We're going to draw it 3 units to the right since we are counting up because it's a positive 3. So from here, I'm going to go to the right 1, 2, 3. And we're going to stop at 1. Okay, so a lot of words for basically representing addition on a number line. And again, not using the bump method, and I'm going to show you how we can kind of combine them to make it a little easier, because I know sometimes drawing a straight arrow, obviously you guys see me have trouble with it. Now let's do the same thing, but this time we want to focus on 3 plus a negative 2. So remember, we put the tail of our arrow at 0. And now, just like we did here, we're going to draw 3 units to the right because it's a positive 3. And we're going to stop at positive 3. So I went 1, 2, 3. That represents a 3. Now I'm at the 3, and I'm going to go 2 units to the left because that negative sign is to the left. And I put the arrow on the wrong thing. Sorry, guys. How's that? And what we're going to see is that 3 plus a negative 2 also equals 1. So notice, we get it right here eventually, we stop at 1 each time. So what can we say about the sum of negative 2 plus 3 and 3 plus negative 2? Does order matter? Well, since we both stopped at 1 here, even with my mistakes, we're going to say order doesn't matter. Order doesn't matter when adding numbers. When adding numbers. And there's a property that is the reason it doesn't matter. Because of the, anybody remember? Commutative. Remember, the commutative property of addition says that you can add in any order and get the same answer. That's why this is only for adding. Okay, if it was subtracting, it'd be something different. All right, we are just going to do a couple more examples on our next page of notes here, and then I will be done with this video. And I'll stop there in case you're still writing order doesn't matter when adding numbers because of the commutative property. So now we're going to talk about absolute value. Remember, absolute value is distance from 0. So as the length of an arrow on a real number line. So how does absolute value determine the arrow length for negative 2? Use the number line supported to provide your answer. Well, if I wanted to represent negative 2, I would start at 0 and I would go to negative 2. The arrow length. How many units is it from 0 to negative 2? Just 2 units, right? Now, remember, our absolute value is how far away is negative 2 from 0. So we could say our absolute value of negative 2 is also 2 units. How does absolute value determine the arrow length for 3? Well, if I start at 0 and I go to the right to 3, notice that's 1, 2, 3 units. Again, because absolute value doesn't care about direction, it only cares about distance from 0, the absolute value of 3 is 3. So it says, describe how absolute value can help you represent negative 10 on a number line. So if I wanted to take the absolute value of a negative 10, okay, we know that equals 10 units. This negative sign here, that's going to be the direction. If there's no sign, that means we're moving to the right, it's positive. If there's a negative sign, it means we're moving to the left. But the absolute value right here, this 10, this is going to be the vector length. And remember, vector is just the arrow. This arrow right here is called a vector. It's a straight arrow, and it's going to go in the direction according to our sign, but its length is going to be its absolute value. And we're going to use that from here on out to help us represent addition on a number line.